Good afternoon, ladies and gentlemen. Pleasure to be here. My name is Thomas Subchurch. I'm the director of Wired Consulting, which is the consulting division of Wired magazine based in London. And for this next session, we're going to be exploring how developments in machine learning is impacting the future battlefield. But in particular, we're going to be looking at how the development of fully autonomous weapon systems and artificial cyber agents are going to be shaping this battlefield. And obviously, technologies like this are going to introduce pretty much unprecedented questions at a moral, political, and military level. And we have a fantastic lineup of speakers to help us do this today. We're joined by Professor Robert E. Burnett, who's the interim Dean of Faculty and Academics at the U.S. National Defense University, Washington, D.C. We're joined by Dr. Sandro Geiken, the founder and director of the Digital Society Institute from ESMT, based in Berlin. And last but certainly not least, we're joined by Jan Tallinn, who, as well as being an active angel investor, was one of the founding engineers at Skype and Kazaa, but also is the co-founder of the Center for the Study of Existential Risk at the University of Cambridge, which I think is the coolest job possible, but also pretty depressing. So what we're going to do is to help kick off this session and to set the scene. We're going to ask each of the individual presenters to give a short 10-minute presentation, which just highlights some of the key themes. We'll then come back to the discussion and we'll open it up for questions. So, Professor Burnett, if you could please kick us off. Thank you.
I guess good morning or good afternoon. It's great to be here. I do need to say something up front. These are my comments. They don't represent the U.S. Department of Defense or the National Defense University. But with that, let me get started with just a couple of things I want to share first. So what's the difference between narrow AI and general AI? The difference between autonomy and adaptivity. And I want to refer to Marvin Minsky, who reminds us that these are all suitcase terms, and they are highly problematic. So let me get started. I want to take you through a couple of scenarios quickly. In December 2017, nations met in Geneva, Switzerland, to discuss the specter of autonomy and AI in weaponry, with great attention toward banning the technology before we fully understand what it portends for actual warfare. How do we discern between legitimate fear for potential deleterious effects upon larger societies and that which may be useful, perhaps even beneficial to operational and strategic gains from such technologies for the purposes of ultimate deterrence that may also serve the same outcome of making safe society? Nevertheless, a more pragmatic note was sounded by Paul Scharr from the Center for a New American Security, who said the following, and I quote, "There are many reasons why a ban seems unlikely. The technology that would enable autonomous weapons is already ubiquitous. A reasonably competent programmer could build a do-it-yourself killer robot in their garage. Militaries are likely to see autonomy as highly useful, as it will give them the ability to operate machines with faster than human reaction times and in environments that lack communications, such as undersea. The risk to innocent civilians is unclear. It is certainly possible to envision circumstances in which self-targeting weapons would be better at some tasks than people. And the most difficult problem of all is that autonomy advances incrementally, meaning that there may be no clear, bright line between the weapons systems of today and the fully autonomous weapons of the future. So here's my first analytical point I'd like you to consider. The international order is deteriorating, and this will impact how states will or will not be motivated to alter their trajectories for the deployment and utilization of AI and robotic technologies in weaponry. Consider the following scenario that I also quote from U.S. Army Colonel Richard Parker's analysis. And the theme is ubiquitous global surveillance. Consider this with regard to human soldiers or machine soldiers. By 2030, the increased availability of commercially manufactured drones, portable cameras, and wireless bandwidth will make it possible to track nearly all activity in public spaces in near real time. The private use of drones, Closed-circuit television and satellites will allow social media users, bloggers, and traditional media outlets to secure live feeds of any event on the globe within minutes and proliferate them immediately. The social impact of live broadcasting of tactical battlefield actions is likely to place extraordinary pressures on small unit leaders. Those of you from the Naval Academy in West Point should think about this. In the future, leaders frequently will need to make highly stressful tactical decisions before a live global audience. In the past, leaders were expected to do the right thing when nobody was watching. By contrast, tomorrow's small unit leaders will be expected to do the right thing with the whole world watching. The increased scrutiny requires leaders steeped in cultural awareness, ethical decision-making, and professional judgment, end quote. If humans will have trouble with these conditions, how are we to design machines for such missions? In fact, some work of this type is already underway at some American defense contractors, where human moral coding is advancing according to specific deontological rules, but nothing of such a magnitude to contend with Parker's description that I just shared. Consider that these soldiers and their comrades will also have to likely deal with simultaneous real-time information attacks in the form of digital and cyber manipulation that may transform reality and therefore public perception. We will, going forward, need to have a complementary cyber soldier tactical unit working alongside the traditional tactical kinetic unit to defend their information reality against our digital adversary, increasingly in real time. Another option, as just mentioned, replacing human soldiers that are capable of making such complex decisions with machines that cannot do so yet, but are simply more automated. And this may not be as much of a burden as we might expect, this being due to the changes that we are experiencing in the international system today. My second analytical point, the commingling of artificial intelligence types with intelligence, surveillance, and reconnaissance technologies and kinetic missions will yield new types of strategic possibilities only after we realize new tactical and operational problem sets. If we describe a crude spectrum of autonomy in drones today, we can do so as follows. On the one end is where we are presently, with human pilots using remote control stick technology. This according to the Horowitz-Shar typologies of autonomy as human in the loop. In the middle is another area where we are also operating today, where drones fly according to incorporated software, hardware technology, and waypoint guidance systems. This typology known as human on the loop. On the other end of the spectrum is a future point of operation that may or may not come over some range of time, where artificial intelligence advances to where we witness what we might refer to as a synthetic or emergent pilot that may result in truly novel and complex flight events that are partially or completely independent of human input. This typology, Horowitz and Shar refer to as a more advanced human out of the loop. This would then be approaching a new form of artificial intelligence, now forcing us to further clarify on a spectrum of narrow to general artificial intelligence. Now, let's refer back to the U.S. Army scenario of ubiquitous surveillance and apply to what I've just described with regard to some powerful ISR technologies that presently exist. Many of you are aware of an American ISR technology of extraordinary capability that was declassified several years ago, known as the Argus platform. As a loitering ISR technology, previously the world's highest resolution camera with a 1.8 billion pixel sensor and the capability to record 1 million terabytes of visual data per day, Argus creates a very powerful, wide area persistent stare for what amounts to, on the one hand, real-time deep observation of dynamic events, and on the other hand, an inventory of forensic events on demand. This technology has likely improved in capabilities since previously acknowledged. Let's apply these capabilities away from an ISR event and toward a kinetic event. Now, let's add in advancing computational modeling and processing power, much of this resulting from recent machine learning technology that can be applied with advancing computational speed that is deployed in the cloud that links the operational spaces. All of this improving on the fly, what we refer to as adaptivity, as a result of the system being fed real-time data for improved autonomous technology outcomes as described by Horowitz and Shar. Let me quote from their work on autonomy. Consider the role of the human or machine control with regard to, for example, acquiring, tracking targets, aiming weapons, selecting targets for engagement, prioritizing targets, timing when to fire, and detonation. I mean to suggest that autonomous, especially fully autonomous technologies that we presently possess for ISR missions, if and when applied to kinetic missions, portend to create very powerful weapon systems of increasing capability in human on-the-loop and human out-of-the-loop logic types of systems. This is where the bridge will be created in which the decision chain for lethal fire can move away from human input to machine decision. We have had this in defensive weapons for some time. We are now on the verge of machine decision in offensive weapons, and this should force us to pause for contemplation. The how of the problem is being solved with increasing speed and precision. The should of the problem, well, it remains stubbornly protracted, vague, and impervious to human politics, biases, and shortcomings. The engineer and the philosopher remain far apart within the conversation, too much so. At important times in modern history, we have looked to the tradition of the American political system, extrapolated to its foreign policy to provide the logic and, in our best moments, the most compelling moral gravity to advance such conversations. We are reminded of the need to have this conversation from other speakers at this event. But as I suggest, this has implications for both tactical and strategic thought. For example, how do we deploy and utilize such weapons for tactical combat effectiveness, as opposed to how we might consider new forms of deterrence schemes and their development and deployment at the strategic level? For this short presentation, I refer back to an important strategic technology thought experiment by Martin Libicki, who is at this conference. In the 1990s, in the journal Orbis, his so-called telemetry of war essay that illustrates how revolutionary technology can thrust forward our strategic thinking to new and extraordinary points of view. This technology is taking us to new strategic visions yet again. In order to think about preparing for some evolving futures with these technologies, let me end with posing some important questions that surround these weapons. Under what conditions are we willing to accept American and Allied combat deaths that result from these kinds of technologies? What sorts of technological kinetic event deaths to American and Allied soldiers do we consider to be unacceptable, and for what reasons? What technological combat kinetic death events do we consider to be of greatest concern in the near term? And what slippery slope arguments apply to them that could cause us to raise our efforts to engage the Russians and the Chinese with regard to controlling the development of these technologies? Consider this potential hybrid problem where technology accelerates lethality and complicates forensics with regard to our ability to know truth and reality by using the so-called deep fake tool. One important distinction at present in the development of autonomous weapons systems is the one in which United States military authorities have stated as policy that decisions on the use of lethal force, even in AI and/or robotic systems, will always be decisions made by humans. This appears to be distinct from our Russian counterparts, so far in that no similar assurance has been made by their authorities, combined with their ongoing technological developments in autonomous weapons. One potential scenario that we should consider is a future conflict where Russians employ autonomous weapons that utilize AI lethal decision-making and combine it with their now demonstrated capability to simultaneously employ social media tools and other digital tools to alter, confound, and manipulate facts toward an engineered version of events, thereby helping them to utilize their kinetic AI weapon in a more effective manner. Artificial intelligence is bringing forth great capability to weapon systems today, and the examples that I've shared with you here briefly serve as a useful corollary to how they may further develop in cyber weapons. But we would be wrong to merely extrapolate our present experience forward with too much confidence in such a future. We need to accelerate our proactive and multidisciplinary tools of analysis to shape the future, to maximize effects of risk mitigation and the advancement of human values. Thank you to CCDCOE, to all the sponsors, to all of you. I'm grateful to be able to add to this conversation. I look forward to learning from my colleagues. Thank you.
Thank you very much, Robert. We're now going to move on to Sandro, who's going to deliver a presentation around achieving AI dominance.
Okay, yeah, thank you so much for inviting me and having me talk on AI and AI dominance. So I just wanted to quickly shed some thoughts on how AI may develop in the future. This is not something that's going on right now or that's even in the beginnings of some, but it's something that I believe is foreseeable to some extent. So what we're seeing right now is that AI certainly carries huge potentials for offense, especially in tactics, with tactical weapons. And as it becomes something that's enabling offense in a very effective manner, it will be interesting for defense to actually counter that. And then once AI is up and running in some areas, defenders will have to think about ways on how to counter AI. And you can counter AI mainly by using an AI against it. So you have to have an AI that learns from the other AI what it does. And this is something that's already applied in cybersecurity, where cyber defense AI is learned by offense AI and vice versa. So you have something like AI versus AI coming up as a scenario for the future. And of course, the question when you're having something like AI versus AI is which AI will be dominant. So something like AI dominance may be an interesting paradigm to develop by militaries. It's certainly a paradigm coming up in cybersecurity right now. Very slowly, will take a long time to develop, but it may be something that will be important in the entire field of AI and warfare. So you can imagine a bunch of AI versus AI scenarios on a tactical level, on multiple different fields. That's mainly going to be the field where AI versus AI will take place. So in actual interactions of systems on a very tactical basis, basic level, certainly between autonomous weapon systems or semi-autonomous weapon systems, AI will play an important role on one side in as much as on the other side. Certainly as well, this is something to develop in intelligence and reconnaissance of mass data analysis. Intelligence entities are thinking about how you can actually subvert that if your adversary is doing mass data analysis, and how can you spoof that, how can you play around with that to make them derive wrong conclusions, or actually conclusions that you would like them to derive. Then also this interesting field played mainly by Eastern powers, information dominance. So something like Twitter bots coming up with AI, sophisticated answers on stuff very fast and very quickly, because this is also, I mean, all these are areas where you have a very complex field that's very fast paced, and that's always something where AI makes a lot of sense to deploy, and we can gain a lot of advantage from AI. So information dominance in terms of controlling the social infosphere, the infosphere at large on a number of IT channels. Cybersecurity, to some extent, AI will play an important role. Like I said, this is only in the beginning, and much of what we see right now, which is branded as AI, of course, is mainly marketing. A lot of the stuff that's being branded as AI in defensive cybersecurity right now is just incremental innovation from things that we've done before, and it's branded and pretending to be more AI than previously, but it's actually a very small, tiny evolution from that thing. But the more interesting thing in cybersecurity is actually that offense is picking up machine learning, and that it seems that machine learning does a lot of very useful things for hackers. So hackers can deploy machine learning in a number of different scenarios to find weaknesses, especially when you're looking at implementation configurational weaknesses. That's something where an AI can learn very quickly and help you very quickly find certain things. So this is something that we're seeing where AI is coming up. And then also, of course, financial market manipulation, which is also something that is very heavily AI-based and where you have to have a lot of AI defense as well. Then there's a bunch of different AI versus AI scenarios coming up, which really very much depend on the kinds of technologies you're using, because this is tactics, and always that depends on what the technologies can actually do. So you're certainly having the game offense versus defense, that you have an offensive AI trying to do something to you, and a defensive AI trying to block that, understand it, or kick it out of your system. But you're also having this idea of offense versus offense, where you're having an offensive AI trying to do something to your system, and another offensive AI trying to attack this other AI specifically and do something with this other AI. So this field is very technical and very tactical. And in this field, actually, the technical AI dominance will be very important. So if your technology is better than that of your adversary at learning in terms of data, in terms of algorithms, speed, computational power, and all these things are the main ingredients here. Another more interesting level is maybe AI versus AI on a strategic level. So on a strategic level, you will have some actors which are better in very specific fields of application of AI, and who will try to leverage their advantage there for a full spectrum dominance. So one example would be if somebody is very good at cybersecurity and at hacking, then they may certainly attack, use this capability, or have a good AI in hacking, use this capability to attack other branches and other kinds of AI, and then try to achieve dominance just in this particular one field of AI. So this is more interesting also for the military planner, because you have you can think about it on a strategic level, conceptual level. You can spend less resources, and you can still dominate the battlefield in a way just by dominating one very specific field that gives you a lot of power over the other fields. And in this area, unfortunately, a lot of cross-domain options exist, and they include very much and very heavily for many actors the civil sphere as well, where you can attack civil targets to dominate military targets, and vice versa. So how do we achieve AI dominance? The first very obvious idea is by empowering yourself. So you can do a lot of standard measures, which are very well-known engineering problems. You can do better data, get more data, have a longer history in engineering. That's always very important to understand the complexity of the problem. You can have a better engineering base, simply hire the better brains or force them to work for you. You can have better algorithms, more computational power. So all these things are very well understood. And this is certainly one path to achieve IA dominance. Dual use is very important in this field as well. So militaries, of course, will take a strong look at civil applications of AI. And I think most civil applications of AI are much more advanced than military applications right now. So militaries will either ask for cooperation in one way or another, or try to buy themselves in, or just simply steal it. And of course, the stealing option is something that is pretty international. So Russians will try to steal from the US and vice versa. And this is something that will certainly go on, where the civil AI capacities come in and can be, if they are understood properly, can very heavily enrich the military capabilities. An interesting element about this, however, is that, and this is, I don't know how much this applies to AI, because there are a lot of open research questions there, but in cyber we have seen one interesting thing, namely you can spend a ton of money and do the wrong thing, and you can spend very little money on the right thing, and the guy who spent 10 million on the right thing will be much better equipped than the guy who spent 10 billion on the wrong thing. I think this is something that we very clearly see in many cases of cybersecurity, where governments who didn't have a clue what they were doing or had the wrong advisors or something spent a ton of money on very specific technologies that weren't even functioning in the end, and others had a better idea of something, some niche idea of something exotic that functioned perfectly and very well and gave much better scaling effects. So this is also something to keep in mind, but there's also something very hard to assess. However, from this field, to assess how different actors empower themselves, a lot of interesting questions arise for which we do not really have good answers right now. These are also questions which are relevant for the market, to assess the field of the IT AI industry. So how can relative AI power be measured? Who's already empowered in which ways? This is also very interesting right now for investors. How will civil applications of AI be weaponized? How big is that gap between civil applications and military applications? To which extent do they have to be weaponized, and can there be shortcuts to all of this, but just simply stealing it, for example, and trying to understand it? So the other more interesting thing to achieve AI dominance, and of course you will do both normally, is just weaken your adversary. And this is something I believe the AI community doesn't really know or doesn't want to ponder. But of course you can just weaken your adversary's AI. You can attack it in design, training, or operation. You can manipulate data. You can manipulate algorithms. You can weaken the implementation or deny availability. And all of these mainly are cybersecurity issues where you can hack somehow into an AI or just feed it false data or do something like that. And these are actually fields which are already explored for 5-6 years by hackers on how to fool an AI into certain decisions, how to attack AIs, that they still look functional but actually do what you want and not what the owner of the AI wants. So this is something that's very interesting, and it's specifically interesting because cybersecurity of an AI is, to my knowledge, absolutely impossible to achieve on the required level. So, like I said, AI makes most sense in fast-paced, complex environments, and we already see that this requires complexity of AI itself, which is far too high for any security measure to be covered. So we have algorithmic complexity, underlying computational complexity in all this implementation environment, microcausal complexity, telling correlations from common cause, from other things, complexity of data, complexity of the overall implementation, including the humans. And complexity is always a very big problem for cybersecurity, the core problem of cybersecurity, if you want. And we know it's very bad at this. And it also has to be an open system to learn from the outside, so it has to be accessible to some extent for me. And the securities will be absolutely impossible to verify. So salesmen will tell you all sorts of stuff on how they secure the AI, but it will be very hard for you to verify if that actually works to the extent that you require that. And subversion, if it is done cleverly, is absolutely impossible to detect until the moment when it's too late. And another interesting thing at that is that strange things can happen when you're attacking an AI. This is a problem as an attacker, especially as a hacker. I don't understand what the AI of my adversary actually does, how it's employed, how it's deployed, in which field, and how it will react to certain things. So if I tamper around with that in a way that the AI engineers don't know how I've been redesigning that systems, a lot of crazy things could happen. So one example could be, I want the US to look bad on the battlefield and to be cited in front of the court of the United Nations. So I want to reprogram one AI in a drone to fire Hellfire missiles into a hospital. But then I don't get the containment right, and all of a sudden all Hellfire, all drones think that hospitals are bad and should be attacked, and fire all their missiles into all the hospitals in the areas. So this is a scenario that's possible from a hacking perspective, at least. So one last thing, there's also what I call the threshold paradox in cybersecurity. So a lot of cybersecurity technologies make you more secure, but only up to a certain level of threats. So this is something that we're seeing in the industry right now. The German industries, for example, deployed all sorts of cybersecurity technologies, and they are much more secure right now against the low-end attackers. But at the same time, they realize that they are much more insecure towards the high-end attackers, because the high-end attackers know how to attack security technologies. Security technologies are software, it's mostly buggy, it has flaws. So for people who can actually do manual code audits or who can use more sophisticated hacking tools, employing more technologies and more complexity to solve security issues only makes the target environment richer. So, and this has created the paradox that at some point when you're buying more tech, you're getting rapidly more insecure when you're attracting a certain level of attackers. But the level is very hard to identify and it's very hard to measure. So people feel safe because they see less attacks, but actually they're more insecure towards the more sophisticated and, of course, the more expensive attacks. And a similar thing could happen with AI. So attacking sophisticated AIs is something that is still very much in its infancy. So the attackers who are now beginning to think about how to attack and subvert an AI That's still a field that requires a lot of development, a lot of thinking. So offense in AI will not be ready for another 5 to 8 years, I would say. But it will be there, and it will be very possible to attack it because the basic concepts are known and basic ideas are there. But the problem is that people will feel safe with AI until that moment. And that's the thing we know from security. If it doesn't hurt, you think you're secure. But actually, you're not. So if you're building all your systems now and you're creating path dependencies, the whole defense contractors are trying to come up with AI solutions in this and this and this and that. And then in 8 years, you have such big fat path dependencies on AI, semi-autonomous systems, and so on. And all of a sudden, the attacker comes and they know a bunch of ways to attack these systems, so they're all malfunctioning. And you have one big bunch of very expensive scrap metal standing around. So, conclusions. I think AI versus AI will be a scenario that will come up. Mixed sets of measures, very complicated, very difficult to predict right now. We have different levels intersecting tactical, strategic, how you're empowered, how you can weaken something. It's very hard to predict. There's a lot of opportunities for strategic surprises as well. An arms race for AI dominance could develop with accidents in AI if attackers are actually attacking AIs and try to understand how they react and what they do. There will be a lot of overlap between the military and the civil world, both in terms of AIs being developed in the civil arena in as much as the civil sphere being part of the target range. And transparency or control of AI is largely impossible without very high cybersecurity. And high cybersecurity, even I would say even medium cybersecurity, is impossible for AI in principle. So people may still be deluded into the thought that AI is safe because nothing will happen for another 5 to 8 years maybe, or nothing serious will happen to that moment. But at that time, it may be too late, and they may have created too many path dependencies. So I think that's the problem I see now with AI dominance developing. And for that, I thank you for your attention.
Thank you. Thank you, Sandro. This was billed as the optimistic panel on AI. I'm not sure if you agree, but I'm terrified. We're now going to pass over to Jan, who's going to give us some idea of the longer-term existential risks.
Right, so good afternoon. Professor Burnett, in the beginning of his talk, mentioned the difference between artificial general intelligence and artificial narrow intelligence, and the fact that people are often very confused about it to the degree that these have become so-called suitcase words. I've been working on a long-term AI safety problems, or now what's now called as AI alignment, for about a decade now. And indeed, like this confusion that Professor Burnett mentioned is really frustrating because the actions that need to be taken are very sensitive to the difference between artificial narrow intelligence and artificial general intelligence. So let me present, like, admittedly, a cartoonish hypothesis why people are confused about it, because the difference is actually rather simple. And also try to explain, like, what the difference is. So philosopher Bertrand Russell once said, and I quote, "Work is of two kinds. First, altering the position of matter at or near the Earth's surface relative to other such matter. Second, telling other people to do so." And I made a similar observation in my work. There seem to be kind of two kinds of people. So one kind of people, they think that the world is composed mostly of people, and the other kind who think that the world is mostly composed of atoms, and the other kind is much, much more a subset. So I think that when people, that is people who think about the world as, in terms of a collection of people, when they think about AI, it means synthetic people to them. So like the questions that kind of arise for them primarily are things about, like, will AI be conscious? How will it be like us? How do we integrate AI into our society? And what are the ethical issues having synthetic people amongst us? Whereas for atoms people, that is people who think that the world is ultimately composed of atoms, including us, it means that the AI could potentially be much more powerful shaper of the atoms and our environment, and thereby our future, than we are. And that basically points to the sort of ultimate existential risk from AI, because we need to remain in control of our environment in order to make sure that it remains inhabitable. So one way to tell the difference between what is narrow AI and what is general AI is to sort of take the view of an atoms person and introduce the concept of agent, which is like very abstract and general concept. It's basically a system that performs some observation or gets some input from the environment, then has an internal model of the environment, and then finally has, as a third component, has actions that it can perform on the environment. So simple examples of agents, the simplest one that I can think of is thermostat. It has temperature input from the environment. It has like a 2-bit or 1.5-bit word model that basically says, like, is the temperature above or below critical range? And then it has output. Like, it can turn on or off the air conditioner or heating. Another example of agent is chess computer. It basically takes input as the state of the board. It models its world is basically the state of the board. It models the consequences of its actions using that model, and then it outputs the next move. Self-driving car uses cameras, radar, proximity sensors to create a model of the surroundings. If you have driven a Tesla, then like you see that on the dashboard, there is a representation of that model. It shows like where the neighboring cars are. And then it uses that model to output actions to drive the car. Human. Well, we have our 5 senses, or 6, some say, that we use to construct the word model that we actually see. There's a lot of evidence that we don't see the world. We see something that is constructed in behind of our brain. And then we use that word model to control our actions. And same thing with AI. It can have multiple inputs. It can have more inputs than humans. It can use that to construct a really detailed word model, perhaps more detailed than humanity, and then use that model to take actions in the environment. Now, from that agent model, you can see there are like 2 dimensions of power. Like one power is like, what are the consequences? How powerful are how impactful are the consequences of your actions? You can imagine wiring thermostat to your nuclear arsenal. So like it's still a stupid system, but it will have massive consequences in the environment. Like once it detects that temperature is too cold, well, boom. But that's kind of uninteresting difference, because using our better word model, we can see that it's a stupid idea to wire thermostat to a nuclear arsenal. However, there's a more interesting dimension of power, which is like how detailed your word model is, how much of the world it encompasses, and how good predictions you can make using your word model. So you can imagine a thermostat. Admittedly, this is a stretch, but bear with me. You can imagine a thermostat that has sufficiently good word model, so it will know that by turning on and off the power really quickly, it can generate radio waves, and it can use those radio waves to make phone calls, and it can use those phone calls to get to the next stage, and then to the next stage, and eventually launch the nuclear arsenal. So generality now refers to the power of the second dimension, like how good a word model is, and what does it encompass? Is it only sensitive to the temperature aspect? Is it sensitive to the neighboring objects, like in the self-driving car, or can it like encompass a lot more like humans, the models of humans or humanity has built have? And now it's interesting, like valuable to realize that there are 2 critical components once the word model of artificial system starts expanding. like one critical component are humans. So once you have starting to get like precisely or sufficiently precise model of what humans will do as a consequence of your actions, you will start manipulating people, and you as an AI system. In fact, like the early signs of that are the Cambridge Analytica scandal and like the alleged manipulation of US elections by Russia. Because you have AI systems that can model the consequences of actions on humans or a population. And the second really sensitive, perhaps even more important subdomain of the world is AI itself. So like once you have AI whose world model includes subversion of itself, so it can model the consequences of its actions on itself. So for example, one simple thing, if it has a world model of the on and off button, it can see like what are the consequences of that on and off being, of the state of that on and off button. So it can search, it can compare the futures where it has been turned off and where it hasn't been. So it will compare the value of its actions that might prevent humans from turning it off. And also, perhaps even more importantly, it can start taking actions that will modify itself, that it will make it improve itself in some sense. So yeah, that's so in conclusion, one reason or one way to try to delineate the difference between narrow intelligence and general intelligence is just look at what this thing is modeling and making sure like that it doesn't model things that we don't want it to model. Thank you.
Thank you, Jan. So I think we've got about 10 minutes of discussion, and we'll open it up to the floor as well for Q&A. I think we're going to start right at the beginning with autonomous weapon systems and also the subject of regulation, which I think has come up a number of times regarding these powerful technologies. A lot of commentators say that despite the best intentions of different international efforts to prohibit or restrict the use or development of autonomous weapon systems, the technology is strategically far too important for any of these initiatives to work. Do you agree?
I do agree so far. I think the evidence of what we've seen so far is that nations are investing in this technology. They're increasing to invest in this technology. And I think that's why I led with my presentation from Shar's commentary that the strategic value and certainly the tactical value of this technology is obviously very important. It will continue to develop. I think also we can look at the record of previous types of weapon systems when new technologies have come into play. For example, if we look at the empirical record of nuclear technologies, there is the example of as those technologies increased in terms of existential threat, we saw the soft technology of arms control and diplomacy then start to accelerate in terms of attempting to control that acceleration. I think it's reasonable, at least at this stage, that we might see something similar happen here. I'm not sure that's heartwarming or reassuring at all with regard to the fact that we might have to wait for something substantial to occur before we have those sort of grown-up conversations. But that's the trajectory I see so far.
It seems that from your presentation, there are two different big problems with autonomous weapons systems. There's the accountability side of things in terms of when there's an accident, finding who's to blame and putting this, the letter to the law to them or responding in some way. But then there's the responsibility side of things as well, which is if we use autonomous weapons systems, there is a danger that a vacuum will emerge where humans no longer feel the cost of war or violence. How do we go about addressing that responsibility vacuum?
Yeah, that's a very important question and a difficult subject. I'm fortunate in that I'm part of a research group between some Americans and Australians at the University of Melbourne. This is a group called the Program for the Regulation of Emerging Military Technology. And one of my colleagues is a very talented international lawyer here from Estonia who works in Australia. And so it's important to engage the lawyers in terms of trying to figure out what the chain of command and responsibility there is. I'm not sure I have sufficient knowledge or expertise to really address this at the level of where autonomous agents really do start to separate from the designers of those agents. And I think that's where much more research is going to have to occur for us to be able to inform, not just in terms of the policy side of it, but also the legal side of it in terms of where that vacuum you're referring to exists. I'm not sure we know the answer to that yet.
And it also struck me from your presentations that we predominantly talked about the use of autonomous weapon systems in major conventional total war scenarios.
Yeah.
And I guess at the moment still, we're predominantly fighting counterinsurgency operations. From what I understand within machine learning and AI, they're not so good, systems are not so good at dealing with ambiguities. They still make quite a lot of mistakes. For example, natural language processing systems confuse and misinterpret double entendre and different other kinds of ambiguities and nuances within the human language. The counterinsurgency operation, theater of war, reigns supreme with uncertainty and ambiguity. Can you ever envisage AI being used in different ways in that kind of theater?
Well, it's interesting you bring that up because I also teach our special operators in a program we have at Fort Bragg, and so I'm working with that group of people as well. And what I can say is that there is a future warfare group at Fort Bragg that is very interested in these technologies. In fact, I'm speaking there in 2 weeks on this subject. Some of the things that we see there are maybe artificial intelligence applied in different sorts of ways as opposed to kinetic operations, more in terms of the PsyOps operations and some of the things that this community or this crowd may be interested in from a cyber perspective is where we're seeing the trajectory there at this stage.
And on this question of, I guess there's going to be gradations of autonomous system, just like we have the gradations on the autonomous driving on vehicles. And so we'll progress through a spectrum, which you highlighted nicely. It struck me that it actually brought me back to one of the early military theorists, Clausewitz, who used the term friction, which interestingly has now been appropriated by the technology industry. And they talk about consumer friction. But Clausewitz first talked about friction, and he talked about it as the uncertainties of war affecting decision-making, the fog of war, the information of war, which clouds decision-making and slows things down. But it seems to me with AI, we almost need to do the opposite. We need to introduce friction into the system to prevent AI running away, making decisions, or acting without some degree of human intervention. Is that a fair assessment? Do you agree with that notion of friction and the reduction? We need to kind of almost find a suitable level of autonomy. Please,
I mean,
Sandra.
I was, as a German, you hear Clausewitz every other week. And I tend to say to some of these scenarios, he was a guy on horseback, so not everything that may be applicable to what we're doing now. But at any rate, I think one problem that we're seeing, and that's a problem we're seeing in many areas where high tech is being developed for warfare or other areas, is that the engineers don't really understand in the necessary depth what the application of the technology will be ultimately. So, and I think that understanding the tactics of warfare will be extremely important for any engineer of AI. So the engineer of AI understands what the AI will actually be employed in, how this field usually operates, what are the basic causal rules and structures, how decisions are being made. And I think that's something where we need a lot more interaction, because in the end of the day, I mean, you can do one thing, you can introduce breaking points where the AI just makes like 10 decisions and then they ask a human operator if that was okay and if they should continue. Or you could just teach the AI to understand tactics so it actually works like a human, and then you got all these elements in there, but that requires a lot more cooperation between tacticians and engineers, I believe.
And I guess another aspect of that relationship between human and machine would be getting the AI, as it gets more sophisticated and starts to reach perhaps into strategic decision-making functions, getting the AI to show it's working out and explain why it is making certain decisions. Because if you think about the AlphaGo competition, when it defeated the Go champion, one of the things the champion originally observed was that he didn't understand what moves the deep learning program was making. They were such an esoteric strategy, but of course ended unfolded that it was a brilliant strategy and it won. So I guess you also need to design a system that shows the working out and the why.
Yeah, absolutely. I mean, that's very important, but it's, at the same time, it's incredibly hard to achieve. I mean, if you're looking at, we've had talks with AI engineers, because in Germany there's one community called Algorithm Watch, and they want transparency of AI in certain decision-making contexts. And the AI owners always tell them, we don't know if it's cloud and mirrors, smoke and mirrors, but if it's true, but they tell them they don't understand their own AI anymore, so they can't explain it to them. And I think to some extent this is true, because we have AIs learning from AIs, mechanisms like that, where it's really hard to understand the final outcome. And as we've seen on that AlphaGo game, predicting that is also very hard. And there are a number of things on why it is hard. You have this incredible complexity, and of course it's supposed to deal with more complexity than humans, so explaining that to humans automatically is something that's contradictory. Then you have the intense technical complexity behind that, and then you also have the time. I mean, if an AI has to explain to a human operator why it makes these decisions, you lose the advantage in time that you actually want that for. So I think it's very important to have transparency, but I think the only place where you can actually have it and understand it is in the design, which again comes back to this point that the designing engineers have to understand very well what they're doing and have to be able to communicate very well what they're doing to military commanders and decision makers.
I wanted to add that, let's remember what zero means in AlphaZero. Zero means zero data. AlphaZero used zero data from human civilization when it learned to play Go, chess, and shogi at superhuman levels. Right? So literally, those communities now can play against an alien. And even more, that alien, if you look at the last sentence in AlphaGo Zero paper, it says that humanity has played Go for thousands of years. It has developed a whole culture and language around this. And AlphaGo Zero took a few days to surpass all that civilizational effort.
I think at this point, I just want to check if there's any questions from the audience. Oh, yep, we have one over there.
Sir, Lloyd Beale from United States Military Academy at West Point. I think this question is more for Professor Burnett. My question is, I think you talked about human moral coding. How would you use that in autonomous weapon systems in order to assure that they don't violate a core law of armed conflict principle such as proportionality or distinction?
Yeah, so I don't think we have this yet. I think we're early in the process. I want to speak carefully to the level of knowledge that I have here, which is not at a high level. I cited some research that's being done by a defense contractor in the early stages of using a deontology, which is right or wrong moral code, in terms of trying to encode that into the decision-making chain. So it's at least theoretically possible that you could start to, over time, make that more sophisticated to various rules within what you cite. But I don't think we're anywhere close to being able to do that at that level at this time.
I think that's a really interesting question, and I think it leads into a theme that Sandro brought up, which was a cooperation between the military and the civilian institutions and populations. Just today, you probably saw in the news that Google announced a new ethical framework, or published some ideas for an ethical framework on how to work with military institutions in the future. Obviously, this is all as a result of the uproar around Project Maven. Is the West at an inherent disadvantage harboring those kinds of views compared to perhaps a country like China or somewhere else in the world where there's a much closer integration between those institutions? That's for everyone.
Well, I might start by saying yes and no. I mean, if I could say it that way. Clearly, I'm a little bit biased coming up in the American educational system, and from that cultural point of view, I think the critical thinking capacity that the liberal arts education system imbues within our approach to asking these questions has produced a rigorous and, so far, a pretty exhaustive way to think about these things that's been quite successful. But in terms of how these programs work, in terms of really what is, in effect, a much higher rate of increasing efficiency over time, we do have concerns about that. And so alternative systems and approaches, you mentioned the Chinese approach to that, does present us with a challenge, I think.
And I guess related to that, we had this theme of domination within AI. And you mentioned, Sandro, the conceptual domination that is required. I think certainly in the press and to the public, machine learning is presented as a unified field. AI and machine learning is seen as this unified field that's advancing in one direction. But when you get into the nitty-gritty, it seems like there's loads of different schools competing over different interpretations, fighting each other all the time. Do we need to reevaluate how these schools either cooperate or perhaps even forge entirely new disciplines in order to get that kind of conceptual advantage?
Yeah, I think, first of all, I have to say I disagree a little bit. I mean, we tend to, as Westerners, because critical thinking is a core part of our values, and we're always biased towards that end.
Yeah.
But if the Chinese and the Russians can just simply throw like tens of thousands of really highly skilled engineers onto the military problem, which our militaries are not nearly capable of because they're all in the private industry doing marketing, I think that in the end of the day, that could be a great advantage. Nobody knows. One of the reasons why nobody knows is because the other thing I mentioned, you can have, and that comes back to the battling schools and different disciplines and so on. Somebody may just have an ingenious idea. That may just be a very tiny thing, doesn't even require a lot of money, and they may be able to surpass everything else just because they have one good idea. This is something that happens a lot in complex high-tech areas as well. So there may be an advantage. At any rate, I believe it is highly important to have oversight over these different initiatives, not in terms of steering them, but just knowing who's doing what and how that works out. And the other thing, which I already said also as well, is that I think it's very important that the AI engineers work together with specific engineers of the field much more closely. That's something we also see in cybersecurity. When we're trying to build cybersecurity for the car, autonomous driving car, the biggest problem right now is that the cyber guys don't understand the car guys, and the car guys don't understand the cyber guys. They both don't like each other, they don't like to cooperate, and so everybody constructs in their vertical, and then in the end nothing works. And I think that's something which we're seeing in AI as well. Also because AI is a very specific expertise, there's only a few people who actually master this, and then getting them to waste their time talking to system engineers who are designing missiles or something like that is difficult.
So real emphasis on that cross-disciplinary approach, I think, is important. Do we have any more questions from the audience? Yes, we have one more in the corner there.
Hi, David Lewis from Zero Day. So, first of all, if you haven't read a book, there's a book that came out 2 months ago, Army of None. It's an excellent book. And the Naval War College put out a report
Is it your book? Or?
No, it isn't.
Okay, good, right.
It's Paul Schar's book. I quoted the author.
Yeah, it's very good. And last year, the Naval War College put out a report on laws, lethal autonomous weapon systems. I would highly recommend reading the report. The report, that's what I'm going to ask about. The report makes a pretty good case that it would very likely result in fewer deaths to have lethal autonomous weapon systems. I'd like you to comment on that.
I'm sorry, say that again. I want to make sure I heard you correctly.
That the report from the Naval War College makes a very good argument that it would result in less deaths. It could be better controlled than what we currently have.
So we'll have
I think that makes a wrong assumption, like really wrong assumption. It makes the assumption that the nature of warfare remains the same, even if you introduce completely autonomous agents into the battlefield. I think the big elephant in the room is non-state actors. Like the big problem with autonomous weapons is that state actors are giving away their natural advantage, which is they have people. But once you have fully automated warfare, you don't need people. You just need money. You need manufacturing ability. or ability to steal the stuff that actually makes the war for you. One of the institutes that I co-founded, Future of Life Institute, published a video called Slaughterbots, a dystopian fictional view of the future where it's no longer to be safe outside or go outside because like anybody can just kill you using the automated weapons.
Did you want to add any other further comments to that gentleman's question?
I've read just a little bit of that Naval War College report, but I'd have to go back at it and look at it more specifically, but I think it's referring to more traditional types of warfare, so I think your point's good in the sense that these as weapons of terrorism or different kinds of warfare, that distinction has to be made. That's an important one.
Yeah, also, I think it's true to some extent because it takes out the heat and hatred of war, and you can make much more rational decisions in a way, much more precise decisions in a way. But the two things that you should keep in mind is, first of all, that you can have malfunctions which scale very highly and scale very quickly. And then like the hellfire on hospitals scenario it could happen. You know, it depends on how you design the architecture. If you're choosing a stupid architecture, which happens all the time, then these effects are possible, and then you can have an attacker who just wants to cause that specific effect, just to make you look bad, or to a third actor trying to escalate something. And so to that extent, of course, there's a huge if in that assumption.
So let me add just one more point to that. So an important study just came out from RAND Corporation that is studying the impacts, and I think this just came out within the last couple of weeks, the application of artificial intelligence to the management and the operation of our nuclear weapons on both sides. And so this adds another element to what we're discussing in terms of a weapon of mass destruction. So that really becomes important in the sense that and I would encourage you to read this, in that it goes to the heart of the matter in the sense that where you start to have sort of an artificial intelligence strategic advisor in a time scale that humans cannot operate in. This is a problem of physics at the bottom line, where you have competing algorithms on both sides advising commanders and really moving beyond the commanders to be able to keep up with it with regard to how to operate those nuclear weapons in a given situation. So the fact that these are existential weapons adds some gravity to this discussion, I think.
Well, I'm afraid that's all we have time for. We've run out of time. We have to go to lunch. But if you could please give these panelists a warm round of applause. Thank you.